Good morning, my dear students. I hope you are all doing well. Today, we will start with with Unit 2, Pure Substances, Chapter 4, Element and Compound, on your chemistry book, pages 51, 52, and 53. In this video, we're going to define pure substance, the characteristics of the pure substance, the ways to detect the pure substances, and we will talk about distillation. Again, let's take a few moments to review some key points from the last video together. Matter exists in three basic states: solid, liquid, or gas. Matter can also be classified as a mixture and pure substances. A pure substance is formed of one kind of material having constant properties. A mixture is made of more than one kind of material having variable properties. Mixtures are classified as homogeneous and heterogeneous. A homogeneous mixture is made of two or more substances forming one phase and which has a uniform composition, while a heterogeneous mixture is made of two or more substances forming different phases of non-uniform composition. The heterogeneous, one phase, while the heterogeneous, different phases. The homogeneous has a uniform composition, while the heterogeneous has a non-uniform composition. This is the definition of a pure substance. We talked about it in the previous video, but let's review it now. What's a pure substance? Pure substance is a material made up of only one type of particle or a component. Pure substance can't be separated into other substances by physical means like the filtration or the evaporation. Examples on liquid, we have water, H2O. It's made up of hydrogen and oxygen. This pure substance can't be separated into other substances by the physical means such as the filtration. Example on solid, we have iron and wood. Example on gas, we have oxygen gas, O2, and carbon dioxide gas. So these pure substances, they can't be separated by physical means, so they are pure substances. Here we have more examples. We have sugar, we have diamond, we have copper wire, gold metal, salt, and hydrogen gas. They are all pure substances that can't be separated by physical means into other substances. Characteristics of a pure substance. All particles of pure substance are identical and have a specific set of physical constants such as the boiling point, the freezing point, the melting point, the density, and the relative density. These characteristics are specific for each pure substance. Let's take water as an example of a pure substance. Water is made up of only one chemical substance, which is water, right? Water is known as H2O. It is made up of two hydrogen atoms and one oxygen atom. One oxygen atom and two hydrogen atoms are bonded together in a specific way. Okay, so this is one molecule of H2O. Each molecule of water has two hydrogen atoms and one oxygen atom. This means that all of the particles in pure water are identical. This shows that water is a pure substance. Water is a pure substance, so it has a specific physical constant. It has a specific boiling point, which is 100 degrees Celsius. Its freezing point is also constant, and it is 0 degrees Celsius. The density is 1 gram per centimeter cube. The melting point is also 0 degrees Celsius. Its color is colorless. It's also odorless, and it's tasteless. So these physical properties are constant for water since it is a pure substance. Ways to detect pure substance. We have melting point. Pure substance melts at a fixed unique temperature. A pure substance has a specific melting point that doesn't change. When we test a substance melting point, we compare it to the known melting point of a pure form of that substance. If the substance is pure, it will melt at the exact temperature. However, if there are impurities or this is not a pure substance, so the melting point will vary. Boiling point. Pure substances also boil at a fixed temperature. A pure substance has a specific boiling point that is constant at a given pressure. If we test the boiling point of a substance and it matches the non-boiling point, so it is pure. However, if the boiling point is lower, higher, or varies, so this indicates that this substance is not a pure substance. Observation of consistency. A pure substance will maintain the same color, taste, texture, and other observable properties. These characteristics will be uniform in every part of the sample because it is made up of only one substance. For example, a pure gold bar will look the same yellowish gold for every angle and through every part. So gold has a yellowish gold color that is or that looks the same in every angle and in every part of it. Texture. Pure water feels the same throughout without any particles or visible differences. Taste. In food or substances where taste can apply, for example, sugar and salt, the taste should be consistent. Activity 1. Obtaining pure water. A scheme of the distillation of salt water. This scheme represents the distillation of salt water. Here we have the salt water. Let's name the materials together. Here we have the stand, clamp, round bottom flask, thermometer. Look at the pointer, thermometer. Here, the heater, the condenser, Erlenmeyer flask. Inside it, we have the distillate. And here we have the homogeneous mixture, which is salt and water. It's one phase, right? So that's why it's a homogeneous mixture. So as a definition, what's distillation? It's a separation and purification technique used for liquid substances. The solution inside the round bottom flask is boiled. Its vapors rise and pass through the condenser where they condense. They condense into what? They condense into droplets of liquid which slide into the receiving flask or the Erlenmeyer flask and collected as distillate. Now we have separated pure substance in the collection container and salt in the original container. This process shows how distillation separates substances with different boiling points. Procedure. Set the apparatus shown above to heat a sample of salt water. Stop the heating after the liquid in the rounded flask totally disappears. Repeat the two precedent operations with the distillate collected in the Erlenmeyer. In the first case, here we have salt water, while in the second case, we use the distillate, which is what? Which is a pure substance. What do we observe on the internal wall of the rounded flask after stopping heating in the two cases? In the first case, in the case of salt water, we observe fine crystals deposited at the bottom of the round flask. The salt will deposit at the bottom of the flask. In the case of the distillate, no trace was observed at the bottom of the flask. It's pure water, so of course nothing will be observed at the bottom of the flask. Conclude. What is the effect of the distillation on salt water? Distillation decomposes salt water into its components, water and salt. What is the effect of the distillation on the distillate? Distillation transforms the distillate, which is water, from liquid state to vapor and then to liquid state again, and no traces were left at the bottom of the flask. What can we say about the distillate collected in the Erlenmeyer? The distillate is a pure substance. Thank you for watching. I have marked certain slides in the PowerPoint with this mark. Please, I want you to copy those slides that have this mark on your copybook, and please make sure to include all the contents shown on those slides. Thank you.